Good evening, friends. Now we'll discuss about turnout and crossover. This is the main points where train diverts from one track to another. So it needs acute adjustment because in that place there are two OH starts, one for main line and one for turnout line. So on the main line the train is moving fast, but in the turnout it is in control speed. Within how much? Within 30 km per hour per 1 in 12 turnout maximum. But in the main line it is moving 100 and above. So it's a very important place in our traction overhead system. It needs acute adjustment. See what is the main points of a turnout on track civil engineering point. The train is facing here from this is facing first will come the toe of switch, then heel of switch, then theoretical nose center, then actual nose center. Theoretical nose center, if you keep it will be so sharp when the wheel move on it, it is losing its sharpness. So actually it is somewhat away from this point, that is actual nose, and then trailing direction. Train is moving from facing direction to trailing direction. This is our crossover. Crossover can be operated by movement of the switch. Now it is set in the main line. The train will come and it will move on main line. But if you move the switch towards main line which is in open condition, the train will divert to the turnout line. The switch, both these switches is moving from left to right and from right to left. So this point is called switch. And here the OH is very critical. Maximum breakdown failure OH is occurring in this place due to wrong adjustment or Pinto profile defective. So many cause is there for OH failure. Any failure needs joint inspection of operating department and loco operating department and our traction distribution department, for which this has happened. Another thing is, if ATT rope will cut, then OH will sag here. One OH, here is not one OH, there are two OHs. If one of these ATD steel rope cut, the OH will sag of one OH and Pinto entangle will take place. Pinto entanglement will take place. So this is the civil engineering portion, the track position. Next we will see the other things. Here we have shown how the actual track is moving. You have seen the track has bended towards the turnout side. There is a bending portion, that is bend rail, and after that it will be again straight. Then it will be straight and the continue for turnout. But for crossover, it is in between two lines. So bent portion, then straight portion, then again bent portion for the next line. That is crossover. Crossover is connecting line between two running lines. Running lines means suppose up and down. But it has not initiated from that place. Means a new line where it has started, that is turnout. Suppose in station area, our loop line started from main line. So that is turnout. But between up and down line, between two other lines, when you are diverting the train from one line to another, then crossover is coming. Crossover is the combination of two turnout. One turnout is on one line and another turnout is on other line. Another turnout is on other line. So try to understand the difference. Turnout is mainly used for initiating a new line. But how we will go to new line from main line? So turnout is used. But crossover is the connecting line between two continuous line. That means it is not initiated from that place. That line not initiated from that place. So this is crossover. It is the combination of two turnouts, and for turnouts only one turnout, one diversion will only be the only one crossover, only one turnout, and crossover is combination of two turnouts. Here we can see bend rail, then straight rail, then actual center. Actual center means the center line of the bend rail where meet the main line center, that is called actual center. Only realistic. Bend rail center where cut the mainline center, that is called actual center. But for theoretical center, it will away from this actual center. That has been also shown. That is actual center. What is actual center? If you extend the center directly by a straight line, they are not using bend portion. They are straightly connecting with the main line, and where it will meet with the center line of the main track, it will be called theoretical center. It will be called theoretical center. So this is a turnout. Turnout is used for connecting a new line from main line where it has started from that place. But crossover is, it is connecting the two running lines, and it is the combination of two turnouts, one on each line. That is crossover. Okay. Now for high speed we are using overlap type turnout, overlap type crossover. So all are overlap type. Initially there was cross type, knuckle type. So better to avoid this type of turnout and crossover, because this is affecting the movement of the train. Why you want to say the probability is more of breakdown in cross type and knuckle type. So use overlap type. Nowadays we are all using overlap type. For overlap type, we have seen in the overlap we have increased one span. First anchor, then it will be raised, then it will come to the crossover point. One span is, but for cross type, anchor must next this crossover OG. Just one span. And knuckle type also that, but we have extended one one span for overlap type. Here it takes smooth changeover from mainline OHE to turnout OHE. But when the train will move on mainline, it will not touch the turnout OHE, because turnout OHE is 5 centimeter above the mainline OHE, So when the train will move on mainline, it will not touch the turnout OHE, because turnout OHE is above 5 centimeter. That is the main adjustment. When it will go on mainline, it will not touch the turnout OHE. If your adjustment is accurate, then it should not touch the turnout OHE. So now we will see what is the system. Friends, here you can see the overlap type turnout. The red is the turnout OHE and black is the mainline OHE. And you know our OHE is moving in zigzag motion, not to form a groove. So before the turnout point, it has two spans. One is anchor span. Then the new OHE has raised this location, so double cantilever. And next it is the turnout point, where loco will proceed to the turnout or go through the main line. This is the juncture point. Here 2H adjustment 2H is very accurate. It must be very accurate. Otherwise, there is a chance of pento entanglement. There is a chance. Most of the OHE failure is happening here. So be careful. You see the data for A cantilever. It has caught the mainline OHE and its encumbrance is 1400 millimeter. Stagger is plus 200 and height is 5.55 or 5.60. The new system they have raised, it is 5.60. And here the new crossover turnout OHE has anchored, that is in red color. It has come to the B point, but what is height? It is 6.05, means 50 centimeter above the mainline OHE. The contactor is 50 centimeter above the mainline OHE. Okay. No, sorry. It has raised how much? 500. In the raised contactor raised 500, and catenary to contact is 400 millimeter, and from catenary to mainland catenary is 500. So this is 500 plus 400 plus 500. It is 1400. And C is normal. But the new OHE at B point will be in the center of the track, just like overlap. Center of the track. So stagger is 0. Next C. Here is normal. 1400 minus 200 and 5.55 or 5.60. No problem. Next is D. This is DN is the critical point. Here D, the new OHE, its encumbrance is 1400 millimeter. Its stagger is plus 300. From track center, it is away from the mast, that is plus 300, and height is 5.60. The mainline height is 5.55 and it is 5.60. 50 centimeter above the mainline OHE. 50 centimeter above the mainline OHE. And in E, you see, it may be 900. Contact to catenary, it is 900 or 750. The distance of contact and catenary of mainline OHE 900 or 750. Stagger has taken plus 200. You see, the turnout OHE is plus 300 and main line which is plus 2, there is 100 millimeter gap between the two which 100 millimeter gap, minimum 50 you have to, you must keep minimum 50 millimeter. Here they have taken it as 100, it is safe. 100 millimeter is the gap, and its height is 5.55 or 5.60. The E means the main line which E means the main line which its height is normal 5.55 or 5.60. Next is F. F purely caught the main line which is, so it is normal. So it is normal 1400 minus 200 and 5.55. And for power supply continuation we have provided G jumper between second cantilever between mainline and the turnout OHE near the second mast 5.6 meter away from the center of the mast, 5.6 meter away from the center of the mast. A continuity jumper or G jumper is provided to make continuity of power supply from mainline OHE to the turnout OHE. It is clear, friends? I think it is clear now. So these things to be maintained very accurately. And another thing is, for better adjustment of the turnout OHE or crossover OHE, you need to provide what is this obligatory mast? Obligatory means which must. Without a mast here near D, this D and E must, it is must here. You cannot avoid it. If you avoid it, then your OH will be unable to adjust your OH. So what is the location of this mast? It can be used where the two tracks separated, mainline track and turnout track. There is started after the turnout point has started to separate from each other, because one is moving right side and one is going through. So there will be a gap. This gap can be adjustable within 150 millimeter to 700 millimeter, 150 millimeter to 700 millimeter. But better adjustment is possible when your separation is 450 millimeter. You provide this mast at that location where the two tracks separated by 450 millimeter. Then this is called obligatory mast, which mast is compulsory. This is why for this its name is obligatory mast. And this is the system. You can provide it from the track separation of 150 millimeter to 700. Within this it is adjustable, but better to provide it at 450 or plus minus something, so that it will permit your span, standard span. You know standard span, which is divisible by 4.5, that is standard span. Okay, the distance from one mast to other mast, if it is divided, can be divided by 4.5, that is standard. But it is also possible that it obligatory is not permitting at 450 to maintain the standard span. So some plus minus you can arrange to keep it in the standard span, but better not to disturb too much. 400 to 500 you keep it, so that your adjustment will be proper. Next is, when the turnout OHE locomotive pantograph will pass to the turnout OHE. You know, turnout OHE is 50 centimeter above the mainline OHE. So from mainline it is in the low, but slowly it will catch the turnout OHE where? from the Pinto horn. You know Pinto horn is a curved side. End of the Pinto is a curve. From there first it will catch a turnout OHE in the curvature portion, then slowly it will leave the mainline OHE and raise 50 centimeter above. Okay, 50 centimeter, 5 centimeter, sorry, I am telling the wrong thing. 5 centimeter above. Turnout which is 5 centimeter above. Previously I have told 50, it is, I am not telling all these things. I am telling it from my memory. So sometimes it is disturbing due to aging. It is 5 centimeter above. Sorry friends, it is 5 centimeter above from mainline OHE. The turnout OHE is 5 centimeter above from the mainline OHE. So the changeover is very nice. The Pinto has two ends and which is curved portion. First, in the bottom side of the curve, the turnout OHE will come when it is in mainline. Then slowly, mainline OHE will also come on the Pinto horn, the curvature portion, and the turnout OHE will be on the pantograph. Slowly it will leave the mainline OHE. Slowly it will leave the mainline OHE because it is 5 cm above the mainline OHE. But where to take this separation? As per the guideline, it has called the distance is 650 plus minus 20 or 650 650 to 700 something. I'll give you the data. That is the distance on the distance of OHE. Distance of OHE, mainline, and here the Pinto will leave the mainline OHE. That point, the distance in millimeter is 650 to 710 possibly. 650 to 700. I'll tell you later. So that should be maintained very accurately. You cannot disturb this thing. Then smooth changeover will not take place and breakdown may take place. So maintain this. This is very much important. Next is the obligatory mass where the Pinto will leave the main line. That distance from the center of the mast must be within 10 meter. Within 10 meter. This is called danger zone. From the obligatory mass center to 10 meter, within 10 meter, the Pinto will leave the mainline OHE and catch the turnout OHE. This accurate adjustment is required here. One is this leaving the mainline and catching the turnout OHE, that is 650 to 710 possibly 710, and another condition they have given from the center of that obligatory mast within 10 meter, that will happen, the catching of turnout and leaving of main line. And when the locomotive will come from turnout to main line, at that time also this condition they must fulfill, otherwise it will be a difficult thing. So I think you can understand this and try to check it. Okay, thank you. Friends, here we have shown crossover between the two running lines. The connecting line is called crossover. And to separate electrically the up and down line, we have provided section insulator. but section insulator can be provided one in trailing direction, one in facing direction. So two types of connection we have shown. What is its necessity? Its necessity is, you see, in the first figure, when a pento is moving on the bottom main line, its pento horn and runner is close. Always pento will be closed near to runner. Runner and this main line which in same elementary section means same section. You see the sectionator is connected with the main line, so here the which will charge the runner with same power. So here mechanical clearance is required, 100 millimeter mechanical clearance plus the length of the pento plus its movement. Pento is moving during speed, sways and lurches. So all these things, and then mechanical clearance. So minimum one plus stagger of the pento. Though pento is kept at 0 stagger, but somewhere it cannot be kept. So plus stagger. So minimum distance must be kept at 1.60. The center of the section insulator to the track center, the distance must be 1.60 meter. This is for what? If your loco is coming from the top upline to this thing, that is trailing direction. If your loco moves trailing direction, section insulator in runner is in the bottom main line, and the other end is in the top main line. So in this case, runner and down main line which will be in same section. So mechanical clearance is sufficient. So here we have provided the distance. What the section to be provided? No. Track center of the section must be 1.60. Do not make it less than this value. Then problem will come. What problem? The two section will be, if you increase it 1.60 minimum. This is 1.60 is minimum. You can increase it. That means away to the top main line, away towards the top main line you can shift it, but you cannot reduce towards the down main line, so that its distance reduced from 1.60 meter. And in the bottom figure, the sectionator has the direction has changed. Here you see runner is the down main line which is connected, so its section is separate. Down upline and downline section is always separate. So the runner is connected with the the top main line OHE. So it is in another section, and main line OHE pantograph will touch the other section. So here electrical clearance will be added. So here also you cannot reduce the this distance less than 1.72 meter. But if you keep the section insulator in 0 stagger, then you can reduce it. You have to calculate. I will show you the calculation. How far you can you can keep it. Okay, you can reduce the stagger here. Here electrical clearance must be given, because runner and the down main line, bottom main line which is in separate section. One is connected with the top main line, another is connected with the bottom main line. So the section is separate, and you have to maintain the electrical clearance from the runner to the running pantograph. So it has increased. It is 1.72. It is the minimum. You can increase it. Okay, friends. Friends, nowadays it is as far as possible it will be avoided this diamond crossing. Diamond crossing means one running track will cross the other running track. That is called diamond crossing. Somewhere, mainly in Nagpur, there is diamond crossing. Where this type of track is there, there will where the conductors in this way. It is overlap type. What we have done, the mainland which is like its way, but the over diamond for diamond crossing, what we have done, we have created two overlap type OHE for the diamond crossing. The train will come and cross the track. Suppose it is coming from the bottom, not bottom, it is coming from the top, from the top and moving to the bottom. This black and blue color Oichi, it will come that from that side and then right to the red Oichi. So it will cross the main line Oichi. So you have provided both side overlap type Oichi, both side overlap type Oichi, and it will cross in this way. But it is more breakdown prone. It is more breakdown prone nowadays. Though we have provided overlap type previously, in past days, it was not this overlap type. Now all this where it cannot be avoided, we are providing overlap type. We are providing overlap. This is called diamond crossing. Diamond crossing. One running track crossed by the other running track. It is not connecting, it is crossing, passing that track. Try to understand the difference. In our turnout and crossover, we are connecting the two lines, but here one track is crossed by the other running track. So it is crossing, diamond crossing. It is diamond crossing. Okay, friends, today up to this, all will stay well, and some confusion is here because I am telling from my memory. So again I have to see it, and I'll clear in the next video. Okay. Good evening. Okay.